Welcome back to Advent of Code 2023, day 5. Alright. Hello, Amara. Have you done this one already? Alright. Start. It's about to start. If you give a seed a fertilizer. Zoom in a bit. Alright, let me get my coffee. You take the boat and find the gardener right where you were told he would be. What were we doing last time? Something about garden producing water. Alright, well, managing a giant garden that looks more like, to you, like a farm. A water source? Island is the water source. Is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Wait, is this going to involve falling sand? Oh, okay. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water for a few days, weeks. Oh no. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac. So it's like a magazine, basically, but more instructional. Just arrived and we're having trouble making sense of it. The almanac, your puzzle input, lists all the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Fine. Seeds. Seed soil map. Well, how are we reading this map? Okay, starts by listing which seeds need to be planted. Alright. The rest of the almanac contains a list of maps. Oh, it's a 2D map, is it? Which describe how to convert numbers from a source category into numbers in a destination category. How to convert a seed number to a soil number. Rather than list every source number and its corresponding destination number one by one, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. So all those spots need to be planted. Okay, that makes sense. So we start at Destination range start, source range start. Okay, it's you don't start from 50, you start... Well, I don't think it matters. It's a range, okay. Starts at 98, contains two values, 98 and 99. Oh! Hang on. I need to read this carefully. Alright, so source range is where we start planting. Range length is how many we plant, so it'd be 98 and 99. What's the 50 for? The destination range is the same length, but it starts at 50. So its two values are 50 and 51. Oh, I see. So it's not describing... This is not describing locations of planting stuff. This is describing ranges of ID numbers. Okay. So the range is 2. So 50 and 51 map to 98 and 99. But the other way around, or they're linked. So ultimately 50 seed number 898 maps to soil number 50. Okay, fine. Hello, DRJ. So it's just a kind of obscure. Well, it's condensing large ranges, so I get why they're doing it like this. So for example, 48. So 50 to 97 or 98 or whatever map to 52 to. Okay, fine. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. Interesting. Okay, so the entire list of seed numbers and their corresponding soil numbers looks like this. So I see. With this map, you can look up the soil number required for each initial seed number. Okay. Fine. So I get that. So this is the same thing for fertilizer, water. All right. So we know how to find soil required for each seed. Okay. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Will this be the first AOC of the year to take more than 45 minutes? Let's read what the actual question is, but I think it doesn't look too scary so far. Using these maps, find the lowest location number that corresponds to any of the initial seeds. I see. There's the lowest location number that corresponds to any of the... Okay, so for each seed number, you just look through... I mean, the brute force-ish approach would just be... For each of these... You just go through every range to see if it falls in that range. If it doesn't, you just map it to a self. Otherwise, you map it according to the range. And then just pick the lowest one. Okay. Not too bad. How big are we talking about? That's not big at all. Oh, no, those are big numbers. Okay, fine. But we don't have to make them... So I think the very naive way that people might fall into is to try and map every integer in one gigantic hash map. but you're just looking at ranges. So for a given seed like this one, you can check each range. Oh goodness. Okay, well, right now we just need to worry about seed to soil. So you can check each of these ranges one by one in constant time without having to check. Okay, fine. And then we're gonna have to think about some sort of script to deal with 5 different things, because we don't have to write the same bunch of code 5 times. So we can. All right. Okay, I think I know roughly how to do this. Let's open up the IDE. Well, that sent my laptop fan spinning. That's really loud. It's probably indexing some code stuff. All right, so 5. Okay, so we just ignore everything after seed to soil map. Okay, so if not line, continue. So we ignore any empty lines. All right. Technically we should say line.strip, because I think if the new line character is included, it will actually pass. It's a bit... strip off the new line, then it would be an empty line. All right, anyway. So if line dot starts with seeds, just put the colon in there, then seeds equals int x for x in line dot split, but ignore the first token. So those are the seeds. Don't need to order them or anything. Elif. And then we have to kind of store these maps. So seed to soil map. All right, so how are we going to store this? We just want to store a range. As a tuple. And so the range will be, so the seed range will be from this number to this number plus this number, just as a tuple. And I mean, it could just be a list of tuples, and each tuple has 3 numbers. We don't need to do much more than that. All right, let's just say seed. Okay, let's just call them the same names here. Seed to soil equals. Just make it a list then. You can't name things like that. Yeah, there we go. Elif. Okay, so if line dot starts with the yeah, that, then say map list equals, oops, seed to soil. So that just changes which map we're looking at, because we're going to need that later on when we use the other maps. Okay. Else, actually, let's also deal with soil to fertilizer. Let's just break the loop there. Break. Okay. All right. So if we get here, all right. So at this point here, we are just dealing with the general line, which is not an empty line. So it's just going to be 3 ints. So it would be map list dot append tuple. Let's put it into a tuple. Int x for x in line dot split. That's it. Just get those ints out. I kind of want to swap them around. I like this one being on the left. So if I do that, then it's like seed mapping to soil. Conceptually, that makes more sense to me. So how do I do this? Let's say, or do I want to map things around? Yeah, let's do that. So temp equals, okay, just do this. We don't need, okay. Map list dot append. So we want the starting number, the seed number first. So it'd be temp 1, and then we want the range next. So temp 2, because that describes the seed range, which is the first thing we're looking for. And then only when we find that, then we would actually go for that to find out where it maps to. Okay. So if we do this, well, let's check then that we've got this map. That should be 0. All right, that looks right. Okay. Okay, so the first problem is, given these seeds, so we've got seeds, we're trying to find the lowest location number. Okay, so we want to define a method which gets the location for a seed. So define, should we call it seed get soil? So basically we look through seed to soil for A, B, C in seed to soil. And let's give these better names. Let's say it's source, range, destination. So we want to, if seed, so it's going to be if seed is less than or equal to S, or strictly less than S plus R. So if range was 2, for example, we would only want S and S plus 1. So we want strictly less than S plus 2. Okay. Return if seed lies in that range, then we want seed minus S, that's like the delta, and then add that to D, and that's the same position in the destination range. All right, so if we get here, then we simply return seed. So seed maps to the same ID number for soil. Okay, so that's get soil. So in the worst case, it uses like 6 steps, 7 steps. And for each of these maps, it's kind of the same. It's not too expensive. It's only using like 20 to 30 steps each. So we don't need to come up with a clever geometrical interpretation of this that'll get it instantly. I don't think. So maybe the problem's not, maybe even part 2 won't be that scary. We'll see. Alright, so finally we want, we just want this, print minimum of get soil seed or seed in seeds. Is that? No. We want the location of the initial, wait, location number. Hang on. Oh! I didn't read the final paragraph properly. No, there's much more we need to do. Oh. Okay. We need to... Okay. Okay, we need to actually use all these maps. Soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity. Okay, so it's a chain. Now, there probably is some smart way of... I could just copy and paste this, like, 6 times. I think I'll do that. So let's just... There's probably some smarter way of extracting these all, or just writing it once in a way that all duplicates, make all the methods you need for each. So let's just, okay. So we have to extract all of these. So what we need to do is we need to go through the full chain. We need to find the soil, the fertilizer, the light, the water for a given seed. And we're supposed to find the... Hang on, so humidity? Oh, humidity to location is the final one. That is the location of where we plant the seed. Ah, I get it now. That's what location means. So these are just ID numbers. Location is the final part of the chain. All right then. So equals... All right, so we're going to need just something for each of these. So what have we got? We've got soil to fertilizer, fertilizer to water. Yeah, we've got to change these. We'll sort it out later. Water to light. Now, I'm already thinking of some clever ways of speeding this up. I could just have a list of strings: seed, soil, fertilizer, water, and then for each of those we automate this. Doesn't matter, I've started on this track. Water to light, light to temperature. Okay, so this is a fairly involved part 1, so I wonder what part 2 is going to be. Temperature to humidity. Humidity to location. Can we just use a quick find and replace? I forget how to do this. Where's... Yeah, we want to replace that. Where's the... How do you find and replace it in this IDE? I mean, I could have done it by now manually, but I need to know. Well, Control F brings up this bar. This is weird. It's like one of the most important things. Edit. Find, replace. Ah! Okay, Control R. This IDE is PyCharm, so Control R is to bring up, find and replace. There should be a button there to... Okay, whatever. Alright, so do that. Alright. Okay. And then, actually, I shouldn't have done that yet, because now we're going to have to change them back to... Alright, well, So here we're going to need fertilizer to water. See now I have to do this again. All right. Water to light. Light to temperature. Make sure we don't get any wrong, because otherwise it's just going to miss out an entire map and we won't even know that it's missing. To temperature, temperature to humidity. Humidity location. Okay. So I think I know how we can speed up this. We don't need to copy and paste this a billion times. Instead, we can have a generic method called define get dest source map. Map is a reserved word. Map list. All right, so it's basically the same logic here, but it's generic, so you can apply it to any map. For srd in map list, if s is source, yeah, so we don't need this. So now we can have a get location for seed. And this just does, so it's going to be get dest seed to soil. Alright, there's gotta be a better way of doing this. Yeah, that if we... Let's just, Okay, I have an idea. Let's just... Let's make a list of all map lists that we can refer to. Stop. There, that's the list of all map lists. So, okay. For map list in map lists, temp equals, so it's going to be get dest of temp map list. So it just applies each map list one by one, and then whatever we end up with should be the location. temp from outer scope. We didn't. Did we use? It doesn't matter. Okay. So we don't need that. So what? So now it's going to be print min of get location of a seed. The seed and seeds. All right. Try running that. Okay, I mean it's instant, and that's expected because these are, it's not that many ranges to go through. All right, well let's hope it's correct, because it's not going to be easy to debug if it's wrong. Okay, it's right. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. Ooh, okay. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range and the second value is the length of that range. So in the first line of the example above, so now we have a range of seeds. Ooh, this is... okay. Could be tricky. Hang on, so... how many seeds are we talking about here? Hundreds of millions. Let's have a look. Each range is about hundreds of millions. 30 million. Oh, that one is like billion. Got a few billions, so can't just go through the seeds one by one. Oh no, we're gonna have to be clever here. So if we're given range of seeds, we can find basically it splits into ranges. So if we have a range of seeds, then what do we get if we try to apply the seed to soil for a range? Well, it's gonna split our range into ranges, right? So there'll be the first portion will map to some range of soils, but then the next portion will map to another range. So basically we'll end up with a sequence of smaller ranges of soils. And then that sequence of smaller ranges of soils will break up into a smaller sequence here, and so on, until we end up with just a... Now, the amount of breaking up won't be like exponential or anything, it'll just... So we'll end up with a manageable number of ranges. It's still quite tricky though. Let's see. All right, so So we have to come up with a way of converting a range list in a map. But once we know that, then we're kind of done, because then we just repeat it for each one. So it's not like we have to write a different method for each. So this is not too bad. Okay, so how do I get started here? Let's at least get our seed ranges. So so do we want to order these, or does it matter? We can order them. There's no reason to order them, because they're all going to be... When you convert a set of ranges, it's all going to get jumbled up anyway in the next... Okay, so let's assume we have a way of doing that, converting each set of ranges through the maps. So we'll end up with a set of lots of little ranges. What do we do then? Well, no. Once we've got that, we just take the smallest, the left end point of the smallest range, don't we? That's just the location. So that's fine. Okay. Alright, so we just need a way of doing this range thing. Okay, so... Seed ranges. So... This time it's going to be... So a range is going to be defined by, let's say, a start and an end point. So it'll be this to this, this plus this minus 1, because I want it to be inclusive endpoints, just make things easier. Right, so let's say seed ranges so let's go from 0 to length of seeds, but take every second step. So it's going to be so the range is going to be and then the end point will be seeds 0 plus seeds 1 minus 1. Yeah, okay. Let me see what this looks like then. Why is it the same thing over and over again? Because that was stupid. Forgot to put the I in there. Okay, there we go. Now we could sort this, which would sort by the first parameter, and that'd be valid, because ranges never intersect. Or do they? There's no reason why they wouldn't intersect. But... they could. For now, it doesn't matter. All right, we'll just leave them as is. Okay. All right, I need to take a couple of minutes break. Yeah, I'll be back in a couple of minutes. All right. The stream has only been going for 50 minutes. That's it felt like it's been longer. All right. So let's okay, I have a bit of an idea now. So we want a generic function like we had before. Okay, but this one will be get ranges. and this. So we feed a source ranges. So it's going to be a list of ranges of sources. So it's not just one source. It's a list of ranges of sources. Okay. And a map list. Now, okay, so what we want to spit out is result equals that. Okay, so for range, let's just say RG in source ranges. So we're given a specific range. Let's say AB. So one range, A to B. We want to see how this gets broken up by the map list. So I'm going to look through each of the ranges of the map list, check how much it intersects with that range, and then accumulate. Oh man, it's confusing, but let's try and build this up. So, okay, so for this given range, we want to see for SRD in map list. So let's change these letters a bit. So we want no, okay, that's fine. So the range in map list is going to be S to S plus R minus 1. Let me just change these letters here. So X, Y, we're going to create a new range. That's going to be S plus R minus 1, because it's, I don't know, S and R are confusing me. Alright, so we've got AB and we've got XY. We want to see where they intersect. These are two ranges. How do you do that? So either one is fully contained in the other, or it intersects off to the side somehow. So let's handle each case. And we want to put all that we find in this dest list here. Okay. All right. So if XY is fully contained in AB, that means the whole Alright, let's just handle each case. There's probably some clever way of writing this in one line, but let's not try and do that. Sorry. If A is equal to X, is this? And Y is less or equal to B. So that means the map list range is strictly is non-strictly contained within AB. That means XY is that means the range we get out of this is gonna be hang on, I need to think this over. Alright, all we actually need to do here is check if AB intersects with XY. So that would mean it's not. So if the only way it they wouldn't intersect is if one is to the left of the other. So in other words, if B is strictly less than X, that means AB is to the left of XY. Or Y is less than A. AB is to the right of Y. So if either of those happen, we just continue. Alright, so if otherwise, they must necessarily intersect. Is that correct? Yeah. Alright, so to find the intersection, the intersection let's say inter 1. It's gonna be the max of A and X, whichever is higher. And inter 2 is gonna be the min of B and Y, whichever is lower. That gets us the intersection range. Is that correct? So if they intersect a bit, yeah, then you take the inner numbers. If one is fully contained in the other, this works. Yeah, that's right. Okay, so inter 1, inter 2 is our new range. So dest.append. Oh no, not dest. We want we want two lists here. We want covered ranges. We want to keep track of all the ranges we've managed to find a cover for in the map list. And we want to keep all the destinations as well. The reason we're keeping the covered ranges is because everything left over maps to itself. Everything that's not covered. So we're trying to, basically, given a range, we're trying to find how many of these map list keys it covers, intersects with, in other words. And anything left over has to map to itself, so that would have to be accounted for. But all the destination ranges gets put into this list. I know that's all really confusing. So we want covered range covered ranges dot append into, so it's going to be into 1 into 2. Okay, and dest dot append, this is the actually we don't need to keep a dest, that this goes straight into the result. So result dot append, we use the map list now, so we say it's going to be inter 1 minus s plus d into 2 minus s plus d. Okay, so that's the mapped range according to this map list. So in summary, we've taken a range, AB. We're trying to find what this range maps to in the map list. So we look through all the elements of the map list, each of these ranges. If it intersects with one of them, then we put the intersection in covered ranges to keep track of it, and we put the mapping of the intersection. So if it was seed to soil, then we're going to end up with soil range, and that goes in the result. Alright. So after we've done this for loop here, we now have a bunch of covered ranges. And we now need to check for leftovers, because anything that's uncovered in A to B needs to just map to itself. So how do we do that? So we say so if not covered ranges, so if we didn't cover anything, then result dot append, we just have to map the original range, so it's going to be AB. Okay. So assuming we have a covered range, we have some number of covered ranges, what do we do now? I think we just want to check the beginning of the covered ranges to see if the left part of AB is covered. We want to check the end of the covered ranges. And then for every pair of elements in covered ranges, we want to take the gap in between. Okay. So beginning. So we want to say if covered ranges 0, 0. So basically the first, oh yeah, covered ranges needs to be sorted. All right. There should be no overlap here, otherwise something's gone horribly wrong. Right, so if the first covered range, 0, 0, is strictly greater than A, we've got a gap, then we want to put A up to the element just to the left of this covered range, because that's uncovered. And this is, I'm sure there's a much cleaner way of writing all this. Let's hope this actually works. And then we want to do the same for the end. So if covered range -1, 1 is strictly less than B, then we have a tail that needs covering. So we want to add B and we want to go 1 past that, so that to B is covered, and we add that to result. Okay, and then finally, for every pair of items in covered ranges, we need to add the gap as well. This is whatever. For I in range length covered ranges, -1. So we've got covered range. We've got 1 covered range on the left. We've got 1 covered range on the right. We want the gap between. So let's just write some numbers here. x1, y1 equals covered ranges I, x2, y2 equals covered ranges I plus 1. So we won't go over the covered range because we're going -1 here, so if x2 is strictly greater than y1 plus 1, that means there's a gap. Then result dot append, it's going to be y1 plus 1, and it will end on x2 minus 1. Alright, that is horrible method. There may be problems here. So if we've done all that, I think we've fully split this one range, AB, into a whole bunch of destination ranges, and all the uncovered parts of that range are also added, just mapped to themselves, like this. So that range is fully split into destination ranges. And we do that for every range in source ranges, so we get a result. Hopefully there's no like overlaps. I don't see that happening, so we end up with a bunch of ranges, okay? Now, let's see if that compiles. All right, so we've got okay, so the final method is get location ranges given seed ranges. All right, so we've got seed ranges here. So we've got temp equals seed ranges. For each map, we do temp equals Get ranges. We want temp map list. So that should take our list of ranges and split it up into lots of smaller ranges in the destination. It's expected to be smaller ranges. Then return temp. After applying all these map lists. Print. Get location ranges. Seed ranges. Let's see if this actually runs. None type is not iterable. The A, B in source ranges. None type object is not iterable. Get ranges, source ranges. None? Why have we got none? How do we ever get a none? Are we even creating a none anywhere? No. None type is not iterable. So we've got the seed ranges. Alright, let's try printing each temp one by one. Let's see what happens. We get none for the first. Oh, because we didn't return anything from this method. Okay. Return result. Okay, so that splits up into ranges. So we should expect this list to grow. Ooh, it is growing. Ooh. Oh my god, it's actually showing some sort of regularity here. I was not expecting this. Okay. So if you look here... Yeah, okay, we'll comment that out. So the final set of ranges is this. Alright. Now what's the question again? Lowest location number that corresponds to any of the initial seed numbers. So it's literally just the left end point of any of these ranges. So it's gonna be... print min of... Wait, so... It's going to be min of locations, just the left endpoint, right? That, if this works... I mean, it seems to be doing the right kind of pattern, it's just whether the numbers are coming out to be correct. Correct? I mean, it's not like I was completely... It's not like I had a lack of confidence in my code, it's just that that method was a bit bulky and I wasn't testing anything as I was going along, so I was a bit worried. But I mean, the general algorithm, man, there must be a much cleaner way of doing this though. I mean, there's a whole branch of science, a whole branch of research around like range algorithms, because they're very important. Range data structures are very important. Like this is an example of a kind of a real life scenario where you could use them. Ranges, finding intersections of ranges. I mean, the key often is to sort by the left endpoint, because they're non-intersecting, right? So once you sort them, then you know where all the gaps are. And it's not going to grow exponentially because it's always like you only add one extra range for each gap. So it's so the most it could grow is basically each range could be split into in theory it could be split into one part for every one of these, and then add one more for the gaps. So basically 2 times this. So a single range could be split into like 60, but in practice it's not really going to happen. It might get split into 2 or 3. So okay, that is exponential, but I think in practice it only adds 0 or 1 each time because of these ranges are huge. So yeah, it's dealing with ranges rather than integers. You have to treat a range as an object, and you have to just maintain the invariance of what that range becomes when it maps. So in this case, when a range is mapped onto a function, it becomes a list of ranges, and a list of ranges maps to a list of ranges, which is the union of the ranges of the maps of the union of the list of ranges, which each of those individual ranges map to. I don't know, I'm getting confused now. It works. Okay, that was I would say this is the first problem that I would say is algorithmically difficult. Like, some of the problems were more only difficult because of the parsing or the reading comprehension, stuff like this. This is the first one where I think you need to. I think a lot of people might get stuck here because you need to think mathematically about these ranges. It's the first problem where you really hit a barrier in terms of runtime. You can't deal with these numbers as is. These are in the billions. You need to be thinking in terms of abstract objects and how those objects transform under these lists. And that's a big leap. That was a very good problem. I quite like that. I've definitely seen similar problems in the past. It's not an entirely original problem. It's a standard. Range algorithms are a standard thing. And also, he's thrown in so many maps, which forces you to come up with some sort of generic thing like what I've done here. This, because otherwise I would be writing like something like this 6 times. Or just copying and pasting it and changing each of the variables, more likely. But I mean, you need to do something like this to save on time. And I could make it even more generic. Like, I don't need to even... If I have this, then I don't have to hard code each of these. I can sort of, each time I see a map here, I can sort of create a growing list of map lists. So map lists doesn't have to be... You don't need any of this. It's just each time you see a name, like seed to soil, create a map list with that name, for example. So you can make this generic, in which case you don't need all these lines. It's just each time you see a new name, create a map list of that form, and then you need some way of realizing that these are chained, I guess. But yeah, whatever. So that took an hour, 15 minutes roughly. Yeah, I like that one. That was a good problem. Let's see. Ooh, this is the first time I've completed before Patagonia. I am starting like 4 hours late. Umaro hasn't started yet. Well, Umaro was in chat, I think. Well, let's check. Are they actually doing it now? Otherwise, let's see who else is. No. Okay. I don't think Umaro. I think Umaro is might not be doing it today. He said he was tired. Umaro is doing Game Maker 2. I don't think this is going to be an easy problem to solve using a game engine. This is a mathematical problem, really. Well, I mean, game engines can do mathematical problems, but you can't really do it using game objects. This is really something you need to go back to the primitive mathematical concepts for. 1.5 hours. What's 1.5 hours? Alright, let's see if anyone else is doing Advent of Code. Oh, I kind of just want to focus on people who are doing Python because, well, there's me. OCaml. I think OCaml is popular in the working world. C++. Time to finish. What, my time? Oh, okay, he's oh, this is a past thing. Alright, anyway. I'll just finish there. Oh man, I keep saying every day I'm gonna start earlier and earlier, possibly at the time that the problem releases, and I always start later and later. Today I was 4 hours late, that's a record. Okay. Let's have a look at the stats. So yeah, that is the longest time I've spent on a problem so far, I guess. But it was about the right amount of time this time. So problem 1, I spent like an hour and I shouldn't have. In this case, I think that was realistic. And of course, someone's completed in 8 minutes 38. But that's quite long, considering that previous days it was like 2 minutes, 1 minute, 5 minutes for day 3. Because day 3 had a lot of parsing, but it wasn't really that hard. 1 minute 22 for day 4. I mean, this one's crazy. 43 seconds to complete part 1. That's pretty crazy. Eventually, you'll start an entire day late, so you'll start when the next is released. At some point, if I do get stuck, at some point I might have to leave a gap because I do want to try and stay on schedule with the remaining days. I mean, that happened in the past, but whatever. And then just see if I can squeeze in a past day where I can. So yeah, this was the longest time so far, 8 minutes 38. Yeah, because you've got like 6 maps, so I can see this. I can see this also tripping up ChatGPT because you've got like 6 maps, and ChatGPT wouldn't really be able to find the link between them all. It might get confused there. So yeah, I think these problems are definitely being designed to try and trick ChatGPT. ChatGPT will probably get close, but I do think it won't create the exact chain for those 6 maps in order. It might get the order wrong. 5 space. I've not seen 5 space on the boards before. Oh, yeah, that's day 2. Alright, well, Looking for an internship. Okay. I mean, that kind of works. I have been contacted by companies in the past because of coming in leaderboards. It was specifically the Google Code Jam, but that was in 2012 when I was actually kind of better at this stuff. Over a decade ago, I got contacted by Google after that, asking if I wanted an interview because they found me in the leaderboards. And then ever since that year, I attempted the Google Code Jam again and again, and I never managed to repeat that performance. So that was my peak. That was my peak programming level until I learned real programming. And once you learn real programming, you get bad at this stuff because real programming is like messy and everything's held together with duct tape, and you're not meant to write elegant mathematical code. You're meant to write hacky stuff and get stuff shipped to the customer. And yeah. The other thing is, let's have a look at this old thing. Okay, massive drop, but then people have had time. Almost approaching 200,000. As long as it works 90% of the time, ship it. Yeah, well, it depends on the field. If you work in healthcare, I think you can raise that 90% a bit. If you work in game design, you can lower the 90%. Yeah, it really depends on the field. Where I worked, which was online video, we could allow for quite a low percentage of working. It didn't matter too much if people get the wrong data on their video, as long as they get the video. Like, we often had stuff like the wrong picture or the wrong, or like, I don't know, the list of recommended videos is sorted wrong or something, or Moana has appeared twice, or sometimes porn would actually come through because before Amazon became a big company, they used to have porn on the Prime Video website because it was just like, it was a tiny company, no one cared, and some people bought porn. The problem is, you know, when they became a big company, of course, they started hiding away the porn. The problem is people bought porn in the past, so they were obliged to still provide that to people who had paid for it. So it still exists on the site, but it's kind of buried away, so it's hidden from the front page. But it still exists. Sometimes it kind of finds its way through into the front page. So I had to actually write porn filters. And my porn filters were usually just SQL scripts saying stuff, while title does not contain erotic and genre is not XXX. Just really stupid, long-winded SQL filters just based on the random stuff I found. And no matter what you did, porn would still seep through. But I was wondering if we should actually start running an AI, train an AI on porn, but did not know Amazon Video had porn. Well, it's mostly a bit buried away, and it's mostly softcore porn. It's nothing hardcore, but it just exists for legacy reasons. People have bought it in the past, so if they bought it, they still own it. So it still has to be there for them, but it just doesn't get advertised. Yeah, so definitely a difficulty spike here, which makes sense. Even part 1, quite difficult to deal with all those maps. I think a lot of people are going to do lots of manual stuff, and they're just going to never finish, because if you try to manually look at seed numbers, if you try to manually write a method for each of those maps, well, you can do it, you just have to do it 6 times. Each star represents up to 5555 users. Why specifically 5555 users? Maybe this number balances according to how many people participate. Yeah. Yeah, it makes sense, because if lots of people participate, they want this to kind of grow or shrink. They want this to shrink. Okay. That's good. Good problem. We've still got 20 days left, so we're only a fifth of the way through. It's starting to get hard now. It was starting to get hard from day one, to be honest. Alright, so tomorrow I'll be back with day 6. Today I've got the Wheel of Struggle, Nightshade to do. Probably have about... Man, I wanted to watch Quantum do his Nightshade submission, but I'm not going to be able to squeeze my own Nightshade submission in before that. Maybe I should start soon then. Alright, anyway, we'll figure this out. Alright, thank you for watching. I saw like 5 minutes of Nightshade and it looked really bad. I mean, it looks like a really nicely designed game. My major complaint is if you die, and you don't really have lives, if you die, you start the entire game from scratch. Which is not good for a point and click, because there's a lot of, collecting this item, use this on this, talk to this guy 5 times, blah, blah, blah. You have to do all that again. But if you kind of write kind of a run book for what you're going to do the next time you die, it's kind of fun, but it's just a really weird way of doing things. So, that being said, you can learn how to escape all the traps. If I can do that, then I'll be indestructible, but I haven't. There's clever solutions to each trap. So, okay, so when your HP goes to 0, you teleport into a trap. And you got to find your way out of a trap, and it's like MacGyver. You I don't know. There's like a candle and a rope and a weight, 10-ton weight about to drop on your head, and there's a rat carrying a key or something stupid like that. You got to find your way out of each trap. If I can work out the solution to every trap, then in theory I would be invincible. So maybe I should devote the first part of my stream to just sitting down and trying to work out each trap, just dying on purpose. Because then I'll have nothing to worry about, right? But it is a really it is a really nice game. It's very open world, more open world than a lot of point and clicks were, I think. Because you got one big 2D grid, and you can go to all different squares and do things in different orders. You can do certain bosses earlier or later as you wish. Certain items you need are all over the place, so it seems to be very cleverly designed, but at the same time that also means that you got to keep track of a lot of stuff. It's not like, I don't know, like Monkey Island, where it was very limited open world, limited to each island. But here it seems you can go everywhere from the beginning. Yeah, it's a nice game. In fact, after the Wheel of Struggle is over, I might try and complete that game if I don't complete it, because it is something to work towards. Alright, so if I do that, then I'll probably start quite soon, because 6, 7, 8, 9. That means I'll finish just in time for Quantum stream. Maybe. Alright, we'll see. Alright, see you later, DRJ. And I don't know if Umaro's tuned in, but good luck, Umaro. This is not an easy problem, so good luck with that. I'll see you tomorrow.